In this video, let's look at how we can solve quadratic equations. Quadratic equations come up everywhere in mathematics. It is essential that you know how to solve them. First, what is a quadratic equation? By definition, a quadratic equation is a second-degree polynomial, and it takes the form ax squared plus bx plus c equals 0. Now, this a here cannot be equals to 0. Otherwise, this first term here will disappear, and then you're looking at bx plus c. So therefore, a cannot be 0. So a has to be non-zero. Now I said here second degree. So the second degree, you look at the highest terms of x's in this equation. So you can see the highest term is 2. So 2, that's where the second degree is coming from. Of course, this x here is power 1. And there's an x here as well. C times x raised to 0. Of course, x raised to 0 equals 1. Okay, so yeah, so if we were talking about a third degree polynomial, the leading term would be x cubed. Okay. Yeah, so this is what a quadratic equation is. A, B, and C, these are constants. So these constants are real numbers. Okay. And so when you are solving for a quadratic equation, you're solving for equation that takes this form right here. Okay. Now the graph of a quadratic equation is a parabola. We'll see later on what a parabola look like, but this is just what you need to know for now. Okay, so how many solutions can we obtain when we solve a quadratic equation like this one? So there are 3 possibilities, and the first one is 2 real solutions. When I say 2 real solutions, I mean you get 2 solutions that are real numbers. In mathematics, we characterize numbers. We classify them into different bins. For example, we have the real numbers, we have complex numbers, we have rational numbers, we have integers. Okay, so the first case, you can have 2 real solutions. Okay, for example, if we look at this equation right here, x squared minus 1 equals 0. If we solve this, we find that x1 equals minus 1 and x2 equals 1. These 2 solutions form, solve. So these 2 are the solutions to this equation right here. And you can see that by just moving the minus 1 to the right hand side. Of course, you will lose the minus sign, so x squared equals 1, and then you can take the square root. So square root of x is equal to plus or minus 1. So that's why we have these 2 real solutions. So minus 1 and 1 are real numbers. So these are 2 real solutions. We can also have one real solution, which is usually a repeated root. You can see here the solutions are distinct, but we can also have solutions that are repeated, and we call that a one real solution. For example, if we look at this equation right here, x squared minus 2x plus 1 equals 0. If we solve this equation right here, we find that x1 equals 1, x2 equals 1. Indeed, all quadratic equations always have 2 solutions, but they could be repeated as well. Okay, so that's what you need to keep in mind. Even though these 2 solutions are the same, we can call it a one real solution, but in fact there are 2 solutions. x1 equals 1, x2 equals 1. It's just that the 2 of them are the same. Okay, and then the very last one is when you get 0 real solutions, which means you don't get any real solution. You get complex roots. So you see the first 2 scenarios here. We're dealing with a case where we have what we call real roots, but you can also have complex roots. Let's look at a specific example here. X squared plus 1 equals 0. Now this equation right here, you can solve it by moving the 1 to the right hand side here, and because it's a plus, when you take it to the right hand side you gain a minus sign. So basically you're solving for x squared equals minus 1. Now if you have x squared equals minus 1, for you to find what x is, you can take the square root on both sides, okay, which is what I do here. So x1 equals the square root of minus 1, and x2 equals the square root of minus square root of minus 1. So the square root of minus 1 is defined as I, and here you also see there's a minus sign here. This is I, so you get minus I. So these are complex numbers. So I is called a complex number. This is the definition of a complex number. When you take the square root of minus 1 like this, it's called a complex number. Okay, so when you take university level mathematics, or like courses like calculus or linear algebra or differential equations, or you will see that okay, let's say calculus, like the first year calculus courses. When you are solving for solutions of an equation like this, you're looking for real solutions. In that case, you would say this equation here has 0 solutions, because we're looking for real solutions. Even though the solution we found, we did find some solutions here, but they're not real, they're imaginary. So these are called imaginary numbers. Okay, so that's what you need to know when you're solving a quadratic equations. Expect 2 solutions, but those solutions, you could get 2 of them being real. You can also find that there's only one solution that's repeated, or no real solutions at all. And this is true for any polynomial. If you have if you replace 2 with an n here, where n is any integer, any positive integer greater than 2. For example, if n equals 5, and then you should expect 5 solutions. Those 5 solutions, some of them could be repeated, some of them could be real, some of them could be complex, but there are 5 solutions. There's a theorem for that if you study more mathematics going forward. Okay, so now the goal for this video is actually to show you ways of solving quadratic equations. It's good to be proficient in these methods. So there are 4 methods that you can use. These are factoring, completing the square, the quadratic formula, which is most people might have seen in high school, and then the graphical method. So basically, the first one you can factor. You can factor you can factor the quadratic equation, or you can just complete the square. The quadratic formula also works because you can just plug in numbers and it will spit out some numbers for you. Now the graphical method, you just graph it and pick out points of solutions. Now let's go through each one of these individually. So the very first one is factoring. So what is factoring? So factoring, is when you are factoring, basically you write the quadratic equation in this form: x plus or minus p times x plus or minus q equals 0. Where this p and q here, they could be any number. They could be real numbers. There could be even imaginary numbers as well. Okay, so they could be anything pretty much. So if you write it this way, now the next step is just to solve for x by setting each factor equals 0. For example, I can set x plus or minus p equals 0, and then I can just move the p to the right hand side, and then that will give me one solution. I'll do the same thing for x plus or minus q. I'll move, so x plus minus q equals 0. And that's true because when you are multiplying two numbers like this, if they give you 0, it means that either this term is 0, or this term is 0, or both of them are zeros. Okay, so that's where the logic is coming from. Yeah, by setting x equals 0 and then solving for x will give you the solution. Okay, so let's look at a specific example. We have x squared minus 5x plus 6 equals 0. So this is a quadratic equation because the highest power is 2 here. Okay. Now we can factor. We can factor. Remember, when whatever I show you here is not the only way. There are other ways you can factor, but this equation right here, if we have x squared minus 5x plus 6 equals 0, this is the same as, I can write it this way. Now look at the terms in red. Minus 2x minus 3x. This is just the expanded form of minus 5x. Notice how if I add minus 2x and minus 3x, if I add this up, I get minus 5x. So I'm basically just rewriting my minus 5x as minus 2x and minus 3x. I did not do anything else. That's all I did. Now, what I can do next, I can take out stuff. I can factor some stuff, and so that's what I did here. Look at the first two terms, x squared minus 2x. So there's a x is common in both of those two terms. Therefore, I can take out an x. I can take out an x here. I can take out an x here. So which is what I have right here. So if I take out an x here, it would mean I have x left over. Now the second term, I take out x. What is left over is minus 2. So you can see these two terms become x times x minus 2. Now similarly, the last two terms, I can take out a minus 3. You can see minus 3 right here. If I take out a minus 3, so the first term, what is left over is just x right here, which is this one. And also 6 here, if I take out a 6 from, if I take out a minus 3 from the second term, I get minus 2. And notice how you can go back to this equation. You can just multiply these terms by the stuff in the bracket. It will give you back exactly this one. For example, minus 3 times x will give minus 3x. Minus 3 times minus 2 will give me plus 6. And this is a good way to check if you did your arithmetic correctly. For example, if I had this term as x plus 2, you know that that's not correct, because if I multiply minus 3 times plus 2, I will get minus 6, which is not what I have right here. Okay. So yeah, so that's now you can see there's a common factor. If you look at this term right here, there's a x minus 2. Also, this term right here, there's also x minus 2. So what we can do is we can take out the minus 2 because it's common, right? We take out the minus 2. If I take out the minus 2, so the first term, what's left over is just this x right here. And then the second term, what's left over is just minus 3, which is x minus 3 right here. And yeah, so we've effectively factored x squared minus 5x plus 6 equals 0 as x minus 2 times x minus 3. And from there, remember from here I said you can solve for x by setting each factor equals to 0. Okay, so that's what I do. So I set x minus 2 equals 0, and then I just move the 2 to the right hand side. I get x equals 2. Similarly, I set x minus 3 equals 0, and then I just move the minus 3 to the right hand side. I get x equals 3. And that's essentially the solution to this quadratic equation right here. You can check if you got the right solutions by plugging these answers back into the original equation. For example, if I put in x equals 2 here for x, so I get a 4 here, and then I get a 10. So you can see now 4 minus 10 will give you minus 6. Now minus 6 plus 6 will give you 0. You can also plug in x equals 3 as well. So the left hand side should agree with the right hand side. Otherwise, you know that you did something wrong, and then you can go back and check your work. Okay. So that's the factoring method. Now let's move on to the next one. Okay, completing the square. Yeah, so you can also complete the square. There are different versions of completing the square depending on what you're trying to do. Sometime when you're trying to simplify stuff, in a future video I'll show you more ways you can deal with completing the square. But for now, what I'm showing here is just how to solve a quadratic equation using completing the square. It's very specific to that for now. Okay, and so the procedure is just to write the left hand side of the equation as a perfect square trinomial. Now a perfect square, I'll show you what a perfect square in a moment, but basically we write the quadratic equation as, you know, as a polynomial that has 3 terms, and then we just isolate for x. Okay, so let's look at a specific example so that will make it clear. Now if we're trying to solve x squared plus 4x minus 5 equals 0, this is a quadratic equation again because the highest term is 2, and so yeah, so we see there's a 1 times x squared plus 4 times x minus 5 equals 0. Now the very first thing that I do here is I move the minus 5 to the right hand side. As you can see here, you see minus 5. Because there's a minus sign, if I move it to the right hand side, I lose the minus sign. That's why I have a plus 5 here. Okay. Now what I do next, so this is the procedure for completing the square. Now I put this 4 in red, plus 4 here, because that's what I will use, and that's how you correctly complete the square. In my opinion, this is the best way, because it removes any ambiguity whether you have a plus 4 or a minus 4. Because sometimes you'll find equations where this actually is a minus sign here. Like, how do you deal with that? So the method I'm going to show you here works for any case so far. And so what you do is you write this equation, and then you add a term to the left hand side and to the right hand side, the exact same term. And that exact same term is just taking this plus 4, you divide it by 2, and then you square it. What you do on the left hand side, you also do the exact same thing on the right hand side. That's why you see this term and this term, they're exactly the same. I can cancel them out, right? And then I get back the same equation right here. So therefore I did not change the equation so far. Okay. Now so one thing I'll say though, when you're doing this, do not square this term. You can simplify the rest of the term, especially the right hand side, but for now just leave this term. Right. You can divide by 2, but don't square it for now. Okay, so yeah, so now I have x squared plus 4x plus, now I divided plus 4 by 2, I get plus 2. And remember this, the square here, I did not touch it, right? I did not touch that. But you can see on the right hand side, I simplified stuff. So you have 4 divided by 2, I get 2 squared, just like this one. And then I squared it, I got 4. Okay, so that's the right hand side. Now This one right here, the left hand side, is actually a perfect square. That's how you get a perfect square. So this perfect square is the same as what you have on the right hand side. Now the trick that I use when I get here is I take this x here and I take the plus 2 and put them into a factor like this. You see this x right here goes straight down. This plus 2 goes straight down. So that's gonna give you x plus 2, and then you square the entire thing. This 2 here is not this 2. You're just taking so if you expand what is in the bracket here, you should get back these terms right here. In fact, if you expand this, you will get x squared plus 4x plus 4 always. So, and then the right hand side, I just did 5 plus 4 and I get 9. Now here to solve for x is very easy, because now we can just take the square root of the left hand side and also take the square root of the right hand side, and that's what I do. So I say when I take the square root of the left hand side, so the square root and the square here will cancel, so I get x plus 2 on the left hand side. Now on the right hand side, when I take the square root of 9, I get plus or minus 3. Okay, now what is left is just to move these 2 to the right hand side, which now becomes this 2 right here is a plus sign on it, so when you move it to the right hand side, you gain a minus sign. So that's why now for x1, the first solution, I'll take the minus sign here. Remember, when you take the square root of 9 here, you get plus or minus 3. So the first solution, I'll take a minus, so that's why I have a minus here. So I get minus 3 and then minus 2. This minus 2 came from this 2 right here, because when I move it to the right hand side, I gain a minus sign. So minus 3 minus 2 will give me minus 5. Similarly for x2, I'll take the plus sign and then also subtract minus 2. So you get plus 3 minus 2 will give you 1. Okay, so that's how you solve this kind of thing for using the completing the square method. This one is good if you're trying to solve the quadratic equation, but if you're just trying to complete the square to a term, I'll do a future video on that. It's a little bit more complicated. Like if you want to simplify a really complicated expression, you can use completing the square. And actually, when you take a lot of math courses, this is something you do all the time. So if you do few this, you will get really good. Okay. So let's move on to the next one. Okay, now the quadratic equation, the quadratic formula. Now the quadratic formula is it's the one formula that I think a lot of students memorize, and this is what it looked like. So basically, you write x equals minus b plus or minus, and then the square root b squared minus 4 times a times c, and then you divide the whole thing by 2a. So that's the quadratic equation. All you have to do is you plug in what b is, you plug in what c is, you plug in what a is, and then it will spit out some answer for you. Two answers. It will spit out 2 answers for you. Okay. This method is actually useful when factoring is difficult or impossible, because sometimes you will find a solution that does not have like a perfect. For example, like you might get like a solution that has a radical. Sometimes that's not easy to complete a square or factor. So in that case, this one here becomes your best tool. Okay, now let's see how we can deal with this. I give you an example here to solve 2x squared minus 4x minus 6 equals 0. Of course, there's a 2 that's common here. I can divide the entire equation by 2 without losing anything. But I'm leaving the 2 in there just for you to see, where the b goes, where the The A's goes where the C's goes, right? In this equation right here. So let's try to solve this equation right here. Yeah. So you just need to pick out, you know, these numbers, right? So you can see A is a constant that multiply x squared. B multiplies x, and C is a constant term. So it's good when you see a quadratic equation like this, you should be comfortable picking out these values right here. Don't mix them up, okay? Because if you mix them up, you put them in here, you get a wrong answer. Okay. Now, if we're solving this equation right here, we just have to stick these values into this formula, the quadratic formula. Okay, and you can see the very first term here we have a minus b, and what is our b here? B is minus 4. So that's why I have minus 4, because there's a minus already. So this minus is equivalent to this minus right here. This minus here came along with b because b is negative, right? So, and then also there's a b right here. So I'm squaring. Remember, there's a b squared right here. So that's going to be minus 4 squared, and then minus 4. So this 4 here came along for the right, and then I have an a. Remember, a is 2, so that's why I have a 2 here. There's also a in the denominator, that's why I have a 2 here. So the ones in yellows are all 2's. The ones that are in like this color, blue or purple, are b's, and then c is in red. And you can see c only appears only once. There are 2 b's, there are 2 a's, and then 1 c, minus 6. Okay, now if you know how to, you know, plug these values into this equation correctly, you should have no problem with this equation so far. Okay, now next we simplify, and you can see that the minus and the minus will cancel. So you get minus 4 will give you 4, which is what I have right here, plus or minus. Now under the square root, we square the minus 4. When you square the minus 4, you lose the minus sign, so you get 16. So that's why I have 16 here. And then you multiply these 3 numbers. So 4 times 2 times minus 6, that will give you minus 48. 4 times 2 times minus 6 will give you minus 48. But also there's a minus sign here. So this minus sign and this minus sign will cancel, so giving you a plus here. So the whole thing will give you 16 plus 48 under the square root. Now the denominator, you have 2 times 2, and you get 4. Okay. Now when you add this up, 16 plus 48, you get 64. So basically you have 4 plus or minus the square root of 64 divided by 4, which is equal to 4 plus or minus 8 over 4, because the square root of 64 is 8. Okay, and then when you solve for x, you get x1 equals minus 1, x2 equals 3. And you can see x1, how did I get x1 equals minus 1? That's by taking the minus sign. Remember, you have 2 options here. You can take the plus, you can take the minus. So first I take the minus, so I say 4 minus 8, I get minus 4. And then I divide by 4. So minus 4 divided by 4, you get minus 1. Similarly, I will take the plus sign this time for x2. So 4 plus 8, I get 12. And then 12 divided by 4, I get 3. Okay, so that's how you use the quadratic equation. Okay. One common mistake before we leave the quadratic formula here is this minus sign right here. This minus sign, sometimes you will see that a student, they'll forget about this minus sign. So pay attention to that, because I've seen a lot of students, you know, they get the wrong answer because they did not take care of those signs. Okay, let's move on to the last method. Okay, so the last method is the graphical method, which means you can graph the quadratic equation, and then you can pick out the solutions from the graph. This is nice because in 2 dimensions, it's very easy to see solutions. Okay. So basically, when you are solving a quadratic equation, you you plot the function y equals ax squared plus bx plus c. Remember, we we set, so basically you set this entire thing equals to y. Okay, and then you read out the x-intercepts. So the x-intercepts are the line y equals 0, or the x-axis. Right. I'll show you in a moment what that is. Okay, so let's look at a specific example: x squared minus 4 equals 0. So if we were to solve this graphically, what would be the solutions? Of course, we know that we can solve this directly. Like, for example, we can just move the 4 to the right hand side. If we move the 4 to right hand side, we get x squared equals 4. And then all we can do is just take the square root on both sides. And you get x squared equals plus or minus 2. Okay? But if we were to graph this, if we were to solve this graphically, all you have to do is just plot y equals x squared minus 4. Remember what I said here. Look at, we were trying to solve x squared minus 4 equals 0. So this, basically you move everything to the left hand side equals 0, and then all the terms here you set them equals to y. That's what I did here. Y equals x squared minus 4. If there was if there was stuff on the left hand side here, you also move them to the left, and then set it equals to y like this. And then this is what you graph pretty much. So I graphed this for you, so this is what it looked like. So when you graph y equals x squared minus 4, this is what it looked like. Remember, I told you in the beginning that a quadratic equation is a parabola. So this is what a parabola looked like. So yeah, so this is what a parabola looked like. And so you can see down here the blue line. So that's the equation we're trying to solve. And then there are 2 axes that you need to know. So this vertical axis here is the y-axis, and then this is the x-axis. The green horizontal line is the x-axis, and you can see x runs from just maybe -3 to 3 here, and then y from -4 to 4, something like that. Okay. So now, how can we read off the solutions from here? So you can see that the parabola it intersects the x-axis at x equals -2 and x equals 2, which you can see from the graph. Remember what I said: the x-intercepts. The x-intercepts. So that's where the x is cutting the x. I mean, so where the parabola is cutting the x-axis. And you can read from here, it is cutting the x-axis right here. If you read down, it's -2. And then also here, when you read down, that's equals 2. So those are the solutions you're looking for. If you are in an exam, sometimes like graphing this might not be viable solutions, depending on how complicated the equation is. So I would say it's do find a way to choose. I guess after doing some practice, you'll see that there are some methods are better in some certain situations. Okay, so just to recap what we did so far, we saw that the quadratic equation can be solved using 4 different methods. These are factoring, completing the square, using the quadratic formula, or even graphing them. And the choice depends on the problem you're solving. And I would encourage you to also practice solving a lot of equations to master these methods. When you see them the first time, they're intimidating, but once you do a tons of practice, it becomes second nature, and you will know which method to choose when you're solving a problem, and you should be fine. Okay. Yeah. So that's a quick intro into quadratic equations. In the future videos, I'll try to dedicate method for just each. Um, Sorry, I'll dedicate a video to each of these methods to look at how we can solve specific problems, and to give you like a flavor of what these look like. Okay. Yeah. Thank you for watching.